predictability. The milkman, the paper boy, evening TV. Did I get delivered here? Somebody tell me, please. This whole world's confusing me. Clouds as mean as you've ever seen. Ain't a bird who knows you're true. Then a little voice inside you whispers.
Have you ever had this problem before?
Oh no, there's no more room in my cabinet. But there's so much wasted space on top. I wish I could reach. I wonder if there's a way.
Boy, do I have the solution for you. The cabinet deck!
Yay!
It's as easy as 1, 2, 3. Step 1. Use the convenient rod to pull the cabinet deck out. Step 2. Spin the rod to lower the box. Step 3. Grab your item from a conveniently located height. Next, reverse all the steps and the cabinet deck will go back as it was before. It's the cabinet deck!
What can we do to optimize this product?
The two most important breakthroughs for this product came in the form of two 4-bar linkages. The first 4-bar linkage shown here was used to keep the hoist level. This was done by placing the two pivot points at the bottom the exact same distance apart as the two pivot points at the top. This caused it, no matter how you rotated it, to remain level at the top. The second 4-bar linkage was used to obtain the two limiting positions of the device. Here, you can see the limiting position when the 4-bar linkage is extended to its maximum distance. It is done so by rotating this rod about this pivot point. Here, at this limiting position, you can see that the hoist completely clears the cabinet, represented by this space right here, and the weight from the hoist will cause a force right here, which will keep the hoist in this limiting position until acted upon by an outside force. In the second limiting position, this is done by once again rotating this rod about this pivot point. Here, this rod is at the smallest distance that it can be from this pivot point. This brings the hoist back in over the top of the cabinet, safely into storage, and you can see the forces generated by the weight of the hoist will keep the hoist at this limiting position until acted on by an outside force.
SolidWorks was used to visualize how our model would set up once we'd actually put it together. It was also used to double check that our analytical calculations were made correctly and that there was no errors in our assumptions that would cause our device not to work. Here in the animation, you can see we had a proper working mechanism. MATLAB was used along with SolidWorks to determine to exact measurements how long each link should be that would allow our device to rotate just far enough so that the tray would come over the edge, however that it would not rotate too far so that the moment on the links would become too great and it would cause the device to fail. At one point we used MATLAB 3-dimensional plot to determine the exact position and distance at which the link must be placed so that it would cause a full rotation without placing too much force on the mechanism and therefore causing failure.
Hey, yeah. You remember when we built that thing?
Before we could start building, we 3D printed our 4-bar linkages using a TAS 3D printer at Clemson Makerspace.
To manufacture the cabinet deck, you start by securing two 2x4 pieces of wood to your 21-inch by 12-inch wooden base. Make sure to correctly orientate the blocks of wood according to the SolidWorks files. After securing the wood, drill the two 3D printed link holders into the base in their correct positions. With the link holders in place, you can now connect the 3D printed links to the bases. It requires a simple connection of a nut and a bolt, providing a smooth surface for the links to rotate on. As discussed earlier, since the base of the links and the tops of the links are evenly spread apart, the hoist will always stay level. Now that the front links are in place, you can connect the back links to the 2x4. Start by drilling the screw into the wood at approximately 7.1 inches back from the front base and 2.8 inches high. Connect the two links in the back using another nut and bolt connection. Make sure to keep all of the connections flush with each other, or else the links will not rotate completely.
To make the hoist, you simply make a 7 by 11 inch box with L brackets in each corner for strength and stability. Rotating rod through the middle of the hoist. Drill 2 holes in the rotating rod and run some thread through it.
Building the hoist, connect it to the 4 links at the top using another nut and bolt connection. Once you're done with that, you can connect your rod and it should be fully functioning.
Yo, how do you think we can improve that?
Now, some possible design improvements of the cabinet deck would include motorizing it. So we left space back here to be able to attach motors to it. And you could attach motors in 2 different spots, right here and right here, in order to automate this movement with the push of a button. You could also add a motor to the back of this rod right here so that you would not have to manually turn the rod to have the container come up. This would increase its ease of use a lot because it would be able to do it with just a push of a button. This would also increase the cost and the setup time for the product itself. So there are benefits and downsides to that, but overall I think it would be worth it to add that. In addition, pulleys could be added right here for these ropes to fit into. This would decrease the friction and make the machine more efficient.